Now it's time for indeterminate powers. 0 to the power 0, infinity to the power 0 and 1 to the power infinity. These forms often arise in advanced limit problems and can be tricky if you don't know the right procedure. Unfortunately, we have one elegant idea to tackle all of these. Let's master it together. Indeterminate powers are infinity to the power 0, 1 to the power infinity and 0 to the power 0. And we will deal with all these indeterminate forms in a common way. What we have? We have a function to the power another function, and we want to find its limit when x approaches some number a. And when you plug in the value of x as a, you get one of these forms. What we will do here, we'll just write this function as e to the power ln and all of this fx to the power gx. And we can do so because e and ln are inverse functions of each other, so they cancel each other. This is the same as this one, fx to the power gx, and we have limit here, limit x approaches a. And by the property of logarithmic, we can write this as e to the power gx can come outside of the logarithmic, since we have this property of logarithmic. Ln of ab is same as b times ln a. We can take the power outside of the logarithm. Next, write this as limit x approaches a e to the power ln fx over 1 over gx. We can do so because this is just reciprocal of 1 over gx. So when you divide by reciprocal, this is same as gx times ln fx. And take the limit inside of exponential. Since exponential is a continuous function, we know when we have continuous functions, we can take the limit inside. So we have this limit as limit x approaches a ln fx over 1 over gx. We have done a great thing here. We have converted these indeterminate forms to infinity over infinity or 0 over 0 form, so that we can apply L'Hopital's rule. See, suppose our limit is in infinity to the power 0 form. So fx goes to infinity when x approaches a, and gx goes to 0 when x approaches a. What happens here? Fx approaches infinity, so ln of fx also approaches infinity. And gx approaches 0, so 1 over gx, that will approach to infinity. So this limit is in infinity over infinity form. And if your limit is in 1 to the power infinity, then fx approaches 1 and gx approaches infinity. What we have done here? Ln of fx approaches 1, so ln of 1 becomes 0, and gx approaches infinity, so 1 over infinity, this quantity will approach to 0. So you have 0 over 0 form here. If your limit is in 0 to the power 0 form, then fx approach 0 and gx approach 0, so 1 over gx will approach infinity, ln of 0, that will approach to infinity also, that is minus infinity, so you have infinity over infinity form. So we have converted our indeterminate powers to the indeterminate forms infinity over infinity or 0 over 0 form, so that we can apply L'Hopital's rule. If we have any limit which are in indeterminate powers, we will follow the same procedure. We'll just write e ln and that whole thing, then we will take the gx outside and send it the gx to the bottom by making it reciprocal. Then we will take the limit inside of the exponential function. Let's see some questions using this procedure. First we have limit x goes to infinity ln x to the power 1 over x. When x goes to infinity, ln x will go to infinity and 1 over x will go to 0. So this is in infinity to the power 0 form. What we will do, we will just write e ln then that whole thing ln x to the power 1 over x. Then we will take the 1 over x outside of the logarithm. Limit x goes to infinity here, then 1 over x ln of ln x. And next, see, we will send the 1 over x to the bottom by making it reciprocal, and its reciprocal is x. Then take limit inside, so we have ln x over x. When x goes to infinity, ln x will go to infinity, and this will go to infinity, implies ln of that quantity will also go to infinity. X goes to infinity, so this is in infinity over infinity form. This is infinity over infinity form. So we can apply L'Hopital's rule. Let's keep E as it is. Limit x goes to infinity, derivative of top d over dx of ln x, and derivative of bottom. Then this becomes, what is derivative of ln x? Chain rule, 1 over ln x. Ln is our outer function, its derivative is 1 over that inside part, then derivative of ln x, which is 1 over x. Then in bottom we have 1. So this becomes e to the power limit x goes to infinity 1 over x times ln x. When x goes to infinity, this x will go to infinity, ln of x, that will also go to infinity, so 1 over infinity, which is 0. So this becomes e to the power 0, which is 1. Next, let's do one example of 1 to the power infinity form. We have limit x goes to infinity, x plus 2 over x minus 1 to the power x. When x approaches infinity, this quantity will go to infinity, and this will go to 1. And how to know that? This is just a rational function, and in rational function, when x becomes bigger and bigger, the dominating term is the highest power of x, and here highest power is 1, so x will dominate. Here also x will dominate, so this will approach to x over x, which is 1. Or you may use the limit also. What we are essentially finding, where this quantity will go when x goes to infinity. So what is this limit? When x goes to infinity, this goes to infinity, this goes to infinity, so infinity over infinity, you can use L'Hopital rule, and by L'Hopital rule, this limit becomes derivative of x plus 2 is 1, and derivative of x minus 1 is 1, which is 1. So this quantity goes to 1, and this quantity goes to infinity, so this is in 1 to the power infinity form. And what is our procedure? Right, e to the power ln this whole quantity x plus 2 over x minus 1 to the power x, and here we have limit. Next, what we will do, just take x outside, it becomes limit x goes to infinity e to the power x times ln x plus 2 over x minus 1. Next step is to send x to the bottom by making its reciprocal. We have e ln x plus 2 over x minus 1 whole divided by 1 over x. Next step is to bring the limit inside. It becomes limit x goes to infinity of ln x plus 2 over x minus 1 whole divided by 1 over x. Let's verify in which form our limit is. When x goes to infinity, we have seen this goes to 1. So ln 1, that is 0. And when x goes to infinity, 1 over x goes to 0. So this is in 0 over 0 form. Our limit in 0 over 0 form. We'll take the derivatives. E to the power limit x goes to infinity, derivative of this quantity, which is 1 over x plus 2 over x minus 1, which is x minus 1 over x plus 2. Then derivative of this whole quantity x plus 2 over x minus 1. Here we will apply the quotient rule, x minus 1 square, denominator square, Then keep the denominator as it is, derivative of numerator which is 1. Then subtract, keep numerator as it is, then derivative of denominator which is 1. And in bottom we have derivative of 1 over x which is x to the power minus 1, and whose derivative is minus 1 over x square. This is our limit. Here we have e. Then let's simplify. See, here you have x minus 1 square. Here this is x minus 1. You can cancel 1 power, and here it becomes x minus 1 minus x minus 2 which is minus 3. And so limit becomes, limit x goes to infinity minus 3 divided by, we can take x square root of, because it is minus 1 over x square, and we can cancel minus also. So in bottom we have x plus 2 times x minus 1. Now our limit is in which form? Infinity over infinity. So this goes to infinity, this goes to infinity, infinity times infinity goes to infinity, and x square will also go to infinity. So this is in infinity over infinity form. So what we can do, let's multiply the denominator. X plus 2 times x minus 1, it becomes x square, 2x minus x which is plus x, then minus 2. In top we have 3x square. And here also you can use L'Hopital rule, because this goes to infinity, this goes to infinity, and by L'Hopital rule our limit becomes derivative of this one, 6x divided by 2x plus 1. Again also we can apply L'Hopital rule. It becomes e to the power limit x goes to infinity 6 over 2 which is 3. So answer is e to the power 3. Or you may just divide this numerator and denominator by x square, and you will also get 3 in the limit. So our answer is e to the power 3. This is our answer. Next, let's do one example of 0 to the power 0 form. X goes to 0 plus, we have function x to the power sin x. And when x goes to 0, x goes to 0 and sin x goes to 0. So this is in 0 over 0 form, 0 to the power 0 form. What we will do, take e to the power ln x sin x, then limit x goes to 0 plus. We can take sin x outside, it becomes sin x ln x. Then this becomes e to the power ln x over 1 over sin x. This is sin x, which becomes cosec x. We are dividing ln x by 1 over sin x, which is cosec x. Now take limit inside, x goes to 0, we have 0 plus. This becomes ln x over cosec x. We are approaching 0 from positive side. Then, and here x approaches 0 from positive side, that's for the reason logarithmic can't allow negative value of x. And this is in infinity over infinity form, so we can apply L'Hopital rule, because when you approach x from positive side to the 0, ln of 0 goes to minus infinity, and sin x from positive side goes to 0. So 1 over sin x, which is cosec x, goes to infinity. So this is in infinity over infinity form, so you can apply L'Hopital rule. So this becomes, here we have e, let's write e to the power limit x goes to 0 plus derivative of ln x, which is 1 over x, then derivative of cosec x, which is minus cosec x times cot x. Now what happens, let's rearrange the terms. Here this is 1 over sin x, this is cos x over sin x, so we have cos x over sin square x. So we can take sin square x to the top, and This 1 over x, you can take x to bottom and we have cos x. This quantity is cos x by sin square x. Now our limit is in which form? Let's see. Plug in x equals to 0, top is 0, bottom is also 0 because 0 times 1 which is 0. So again we can apply L'Hopital rule. So e to the power limit x goes to 0 plus derivative of sin square x, which is 2 sin x, times derivative of sin x is cos x, divided by, we will apply product rule here. Keep x as it is, derivative of cos x is minus sin x, then plus derivative of minus x is minus 1, and keep cos x as it is. Now let's plug in x equals to 0. Sin of 0 is 0, cos of 0 is 1, so top becomes 0. Bottom we have 0 times 0 plus this is minus 1 times 1, cos 0 is 1. So this becomes minus 1, 0 over minus 1, which is e to the power 0, which is 1. Okay, by this example we have covered all indeterminate forms. Now we are ready to apply L'Hopital rule for any given indeterminate form. Practice as many questions as you can. Then also comment if you have any question. Thank you. Have a happy practice.